Okay, today what we're going to be doing is I'm going to be showing you guys the review for Algebra 1 so that you guys can take the test. Now this first page isn't very important, so I'm actually going to skip it. Except for this bottom part, I just want you to see the differences between geometric and arithmetic. Okay, so geometric is this little curved part. Alright, remember geometric means that we're multiplying each time. Okay, so it's a curved or a exponential graph. This one being straight, the linear graph is arithmetic. So this is geometric arithmetic. So that's the difference between the two. So if you make a graph and it's arithmetic and it looks like this, you did something wrong, and vice versa. If you made a geometric graph and it turns out like this, you did something wrong. Okay. Now, when you look at the actually, let me just turn the page. All right. So we're gonna look at the first part. So when we look at this first part, it says, given the term and the ratio or difference, find the recursive and explicit formula. So what we're first looking at is you're looking at, you have A11 and you have D equals 3. So we know that D makes it arithmetic. And we know that R makes it geometric. Now each of these have their own little formula to actually solve for a an equation, the recursive and the explicit equation, and I'm going to only show you a couple of them just so that you guys can practice the two below them. So these first two, I'm going to do these first two right here. The first step is you need to figure out how far is A11 from A1. The reason is we need an A1 enabled to do this formula. Remember, this formula is AN equals D times N minus 1 plus A1. So I need A1 because I already have the D, but I need the A1 in order to solve for this. So I do step 1. How far is A11 from A1? Well, A11 minus A1, meaning 11 minus 1 is 10 things away from each other. Okay, so that's step 1. Step 2. Now, with arithmetic, it changes from arithmetic to geometric, so this is not going to be true always, but this is what we do next. Step 2 would be to take this 10 and multiply it by the D itself. Okay, so we're going to take that 10 and multiply it by the D, so we're going to take 10 times 3, and we're going to get us 30. Okay, that's step 2. Step 3 is to take the original number right here, that's 16, and subtract 30. Okay, 16 minus 30 gives me negative 14. So that means my A1 equals negative 14. Now, we need our recursive and our explicit. Now, recursive is pretty easy. This is always AN equals AN minus 1. Okay, we have that part. And then we put plus, since it's D, we're going to put plus whatever this number is. So plus 16. That's the recursive. The explicit, you're going to have to now take this A1, plug it in here, take this D, which we got right here, plug it in here, and then reduce. So you'll get AN, so this is one answer. Let me circle it off so you don't get confused. You have AN equals, our D is 3, N minus 1, plus negative 14. Okay? Now, my next step would be to take this 3 and distribute it through these two things. So that gives me 3n minus 3. And since this plus negative 14 is here, I'm just going to put minus 14 since it means the same thing. My last step is to combine my like terms. I have a negative 3 because there's a minus sign in front. Negative 3 minus 14. That gives me negative 17. So those are my two answers right there. This is explicit, this is recursive, this is explicit. So now I'm going to do this one over here. Okay, same steps, same ideas. Step 1, how far away is A43 from A1? So I take A43 minus A1, which gives me 42 away. That's step 1. Step 2 is to take the D and multiply it by this number. So we take 42 times the D, which is negative 7. When we take 42 times negative 7, we get negative 294. Okay, so that's step 2. Step 3 is to take the original number, which is negative 250, subtract. Now notice I put the subtract there before I even look back at this. I'm going to subtract whatever this is. Now since this is a negative 294, that actually changes both of these negatives into a positive. Okay, so now it's just negative 250 plus 294, which gives me 44. So I know my A1 equals 44. Okay, so now that I got my A1, I can find my recursive and my explicit. My recursive is AN equals AN minus 1 minus 7. Now it's technically plus minus 7, but I'm just going to shortcut it since plus minus 7 just means the same as just minus 7. Okay? And then the explicit formula, remember, is AN equals the D being negative 7. N minus 1, that does not change, plus 44. So remember, this is the formula we're using right here. Okay? So when I distribute this negative 7, I get negative 7n. And because I have a negative 1 here times a negative 7, it becomes a positive 7. Plus 41. Okay? So positive 7 plus 41, since it's like terms, is negative 7n plus 48. Oh, sorry, this is 44. That's where I was messing up. Okay. Plus 51. And those are your two answers. This is your first answer, the recursive formula. This is the explicit formula. Remember, these are two separate equations. They mean the same thing, but they're two separate equations. Okay. This one right here, these two right here, I'm going to have you guys try that out on your own if you want. If you don't, you can go straight to the test. But otherwise, you need to be doing those two. But I'm going to give you the answers. So I'm going to give you the answers in about 5 seconds. So pause the video if you don't want the answers. Okay. This first answer should be AN equals AN minus 1 plus 2. That's the recursive. The explicit is AN equals 2N plus 106. And A1 should have been 108. Okay. This recursive is AN equals AN minus 1 minus 3. The explicit is AN equals negative 3N plus 6651, where A1 was 6648. Okay, so those are arithmetic. Now we're going to go to geometric. Okay, so geometric, you'll know it's geometric because we have an R. The formula for this one is AN equals A1 times r to the n minus 1 power. Okay? So, what we're going to do first is we're going to do the same thing we did up here. We're going to figure out how far away is this from A1. So A3 minus A1. That gives me 2. The difference now is that instead of multiplying these two numbers, is we're going to take this number and raise it to the power of this number, meaning I'm going to take 5 and raise it to the power of 2, which 5 squared, meaning 5 times 5, gives me 25. Okay? The next part is now I take this 25, and instead of subtracting from this, I'm going to divide. So I'm going to take 250 and divide it by 25, which is going to give me 10. Okay? This is my A1. The next thing I'm going to do is now I have my A1, I need to do my recursive and my explicit formula. Now, since before it was an equals an minus 1 plus whatever this number was, instead, this time we're going to multiply by that number. So I'm going to put times 5. Because that's the difference between R and D. Now, we have we have A1, so AN equals, A1 is 10, R is 5, and this is N minus 1. This is the recursive, this is the explicit. Recursive, explicit. Okay? Now this one over here. We have A4 equals 2 and R equals 1/3. So what we're going to do is first we're going to figure out how far A4 is from A1, which is 3 away. Then we're going to take the R, which is 1/3. So if you did this in your calculator, you're going to put parentheses 1 division sign 3 to the 3rd power. This is going to give me 1/27. Now, the next step is a little bit tricky. You're going to take that 2, you're going to divide it by parentheses 1/27. That's how you put that in your calculator. This will give you 54 as your A1. So it's step 1, step 2, and step 3. So we know our A1 equals 54. So get a recursive, AN equals AN minus 1 times 1/3. And then AN equals 54. Because remember, I'm using this little formula right here. So A1 is 54 times R, which is 1/3 to the N minus 1 power. Okay, so you guys can try the next two. I'm just going to give you the answers. And in 5, 4, 3, 2, 1. This should be AN equals 8 to the 2, N minus 1. AN equals AN minus 1 times 2, where A1 is 8. This one right here, AN equals 3072 times 1/4 to the N minus 1 power. And the recursive is AN equals AN minus 1 times 1/4, where A1 is 3072. Okay, now, this next part is actually easier than you think because things have groups. So essentially, I'm going to put a 1, meaning arithmetic. I'm going to put a 2, meaning geometric. Arithmetic, geometric. It's arithmetic if the only thing you're doing is adding or subtracting. It's geometric if you're multiplying whatsoever. Arithmetic if you're only adding or subtracting. Geometric if you're multiplying whatsoever. Now if it's linear, it is arithmetic. So that means that arithmetic and linear go together. You can't say something is geometric and linear. Okay? Nonlinear always goes with geometric. Now, growth or decay, it just means is it multiplying by number greater than, is it adding or multiplying by number greater than 1? Should put an or there. Decay means is it subtracting or multiplying a number less than 1. This top part is for arithmetic sequences. This bottom part is for geometric sequences. And I'll show you what I mean by that. So this first one, we look. Is there any multiplying going on? No. There's no number in front of here. There's no multiplication sign behind there. So I automatically know this is arithmetic. And because I know it's arithmetic, then I automatically know it's linear. These two go hand in hand. The last part is a growth or decay. Now we look up here. It says arithmetic plus minus. Well, plus means that it's growth. So I'm going to put growth. Okay? The next one, look for any multiplication. Well, this 5, since it's next to this A, means it's multiplying. Okay, so then we're going to be looking at, we know it automatically is geometric. Because we know it's geometric, we know it's nonlinear. And because we know it's nonlinear, now we're going to look at this part. So since this is geometric, is the number greater than 1 or less than 1? Greater than 1 or less than 1? So the 5 is greater than 1, so that means it's a growth. This next one, no multiplication. Automatically know it's arithmetic, linear. Are we subtracting? Yep. So that means that it's a decay. Now, on your guys' test, you're also going to get stuff that's not in recursive form, but also in explicit form, meaning like if you have an equals 3n minus 6. Yes, you see multiplication here, but this is still an arithmetic sequence because remember when on our top part, when we're doing arithmetic sequences, the explicit formula should look like that. So remember, let's go back to this. So this looks what a arithmetic sequence looks like. This is what a geometric sequence looks like in an explicit. These are all recursive, so just know that when you get to the test. This one should be geometric, you're multiplying, nonlinear because it's geometric, and then number's bigger, so it is growth. Number, okay, so once again, this is going to be geometric, nonlinear. This number is less than 1, so it's a decay. And finally, this is tricky. Growth, nonlinear. Now, if I took 9 divided by 8 in my calculator, would that be bigger than 1 or less than 1? The answer should be bigger than 1, so this is technically a growth. Okay? All right. So these are the word problems. And they're a little tricky, but they're a lot easier once you get the hang of it. What you always need to do is find your A naught, so that's your A naught, and your interest rate. To get the interest rate, we first look at this. It says 8% loan. So we know that it's 8%. But we can't deal with 8%, so we need to turn that into a decimal, so that becomes 100. Divide by 100, that gives me 0.08. Now, these are always given to you as a yearly rate. So what we're going to look at is we're going to look at what type of compound rate this loan has. Future is trying to get a nice new whip. He figures out he needs a loan for $40,000 in order to get his new ride. Since his credit isn't that great, he can only get an 8% loan, and he makes a $600 payment each month. So that month is where our key thing comes in. That means that we have a monthly compound rate. So I'm going to divide by 12. And now when I divide by 12, that gives me 0.00667. Now, you always need to be adding 1. So I'm going to add 1 here, and I'm going to get 1.00667. So that is my interest rate. And my A naught is how much was the loan to start with. So the loan here is $40,000. So that's my A naught. Now, to get your A1, you always take your A naught, you multiply it by the interest rate, and then finally, depending on if it's a savings account or a loan, we got to figure out what's happening each month. Well, it says he's paying off $600 each month. That means that we're taking away from the loan each month. So that means we should be subtracting $600 each month. Okay? So that's what we're going to do each time. This first one, what it gives you is it gives you 3966.80 A2. Now, this is month 1. Month 2, we don't start with $40,000 again. We start with what our ending balance was from last month. So we start with 39,666.80, and we multiply by the same thing. We multiply by 1.00667, and we subtract 600. That will give me 39,331.38. So I'm going to do this 6 times. I'm going to go H3. All right. So then A3, once I do this whole thing to this number, my answer will be 38,993.72. Month 4 will be 38,653.81. So on and so forth. That's how that works. Okay? Now, on all these problems that I gave you, they have monthly compound rates. On the tests, you could have anything be up to, you could have quarters, you could have monthly, you could have semi-annually, you could have daily, weekly, so on and so forth. So know that this number is not always going to be 12. For example, if it's quarterly, it would happen 4 times a year, so that would be divided by 4. If it was weekly, it'd be 52. If it was daily, it'd be 365, so on and so forth. If you need to rewind that part I just said, do so you can write it down somewhere. Now, I'm going to do the next one. That's all I'm going to do with these. So JT has been saving up for college. She puts her money in a fund that gives her 11% and compounds monthly. If she saves up $100 each month, find the first 6 months of her saving up. Okay, so A naught. So actually, first interest rate. We got 11%. We have to divide that by 100. That gives me 0.11. Then I have to divide that by 12. That gives me 0.009167. Remember to always add your 1. That's 1.009167. Okay? So, what I'm going to do now is I'm going to figure out how much money did she start out with. Well, it says she's putting in $100 each month, but that means that she didn't start out with any money in the account. So we're going to put a 0 there, big fat 0 for A naught. To get the first month, we take the previous thing, which is A naught. So we take 0 times 1.009167, and we add 100. Because that's how much money she's saving up each month. So this is her current balance times the interest rate. Then she's going to add more money at the end of the month. And that's going to end up with $100. The reason why is anything times 0 is going to give you 0 plus 100, so on and so forth. A2, it's going to be now our remaining balance from last month, which was $100. We're going to multiply that by the interest rate. Then we're going to add how much money we're putting in this month, and we end up with something like $200.92. We're going to keep doing this for 6 months. So now we've got $200.92 times 1.009167, and then we add the 100 again. That gives me $302.76. We'd keep doing that for so many months, but that's the idea. Remember, so if it's a loan, you're subtracting each month. If it's interest rate or you're saving up something, you're adding each month. All right. Now the graphing. The graphing part is a lot easier than we think it is. So, this is the recursive formula. So this is how this works. What you always start out with is you start with an XY t-chart. You go 0, 1, 2, 3, 4, 5. What these represent, all right, is 0, 1, 2, 3, 4, 5 is A0, which is already actually given to us, A1, A2, A3, A4, and A5. Now, what a recursive formula is it tells you this one thing. It tells you to take the previous, to get to the next term, we take the previous term and add 6. So first we're going to start out with A0, which was 4. It tells us that. To get to A1, we need to take A0, which was 4, and add that 6 to it. So we're going to take 4 plus 6, which is going to give us 10. To get A2, we take that 10, we add 6, which gives us 16. To get that 3, so we take 16 plus 6, gives us 22. To get the A4, we take 22, and we add 6 to get 28. And then we do that 28 plus 6, and that gives us 34. Okay? So then what I would do is I'd graph it. So I'm going to look at this. I only graph the first couple. It's okay, I only first graph the first couple. But you notice I made a straight line, which is what we wanted since we're making an arithmetic recursive formula. Now when I do that with this thing, I do the same idea. I took A0, which is 0. A0 is 0, 0, 3. Took that 3, subtracted 7. So 3 minus 7 gives me negative 4. All right, negative 4 minus 7 gives me negative 11. Negative 11 minus 7 gives me negative 18. Negative 18 minus 7 gives me negative 25, so on and so forth. So that is a recursive arithmetic sequence. Now, geometric sequence. On your test, you're going to see this 3 not there, but actually in front of the an minus 1. You're going to see it look like that. It means the same thing. It just means take whatever this thing is and multiply it by 3. Okay? So you start with 5, because that's what it tells you to start with. All right, so we go through the whole process. It's going to say take the last number, multiply it by 3. So if we take 5 times 3, we get 15. Okay? 15 plus 7 gives us 22. Now, we take 22, multiply it by 3, that gives us 66. Plus 7 gives us 73. We keep doing that all the way down, and we get this as our graph. Now, I'm not going to actually graph these, but they would end up looking something like that if I did graph it. When you do this, you can go up by 5, 10s, whatever you want to. You don't have to go up by 1, so you can actually graph this entire thing. Same thing right here. All right, so the 1/3, all I did was take 729, times it by 1/3. Remember, in your calculator, always put things in parentheses if it's a fraction. So it was 729 times 1/3 plus 3 gave me that. 246 times 1/3 plus 3 gave me that, so on and so forth, all the way down. Okay? And then finally, our last is explicit formulas. Now, explicit formulas are actually easier to understand than recursive. The reason is that, once again, I'm going to put 0 through 5 here. Remember, this stands for A0, A1, A2, A3, A4, and A5. But instead of having to take the last term and do something to it, I can just plug the number in for n itself. So if I plug 0 in for 5, that's 5 times 0. That gives me 0. Minus 4 gives me negative 4. Do the same with 1. 5 times 1 equals 5 times minus negative 4 gives me 1. 2 times 5 is 10, minus 4 is 6. 3 times 5, so on and so forth. Now, remember when I said this thing? Remember, this is going to give you a straight line. Reason why it's going to give you a straight line because this is what arithmetic looks like as an explicit formula. So these two things are arithmetic. Okay? Now, same idea here. That's all I did was I just plugged the numbers in for n. So it'd be 7 times 0, which was 0 plus 3, so on and so forth. This part's a little bit trickier because you have 0 through 5 now, and this time plugging it into the calculator is not as easy as it looks unless you know what you're doing. Okay? So for example, for this first one is 0. So what I'm going to do is I'm going to show you how to plug that in. So since it's 0, we have 4. Put 4 in, parentheses 6, close the parentheses. Then to put a power like it wants us to, we push this little caret key right here. Right here. And that puts the little thing right there, and we're going to put 0 in for that. And it's going to tell us the answer, which is 4, which is exactly what I wrote down here. If I do the same thing with 1, 4, 6, caret key, 1, it's going to give me 24, which is what I wrote down right here. If I keep doing this, this is what it's going to look like. And remember, these are what geometric sequences look like. And they're going to be curves. Okay, for both of these, they're going to be curves. And now I'm going to show you how to put this one in your calculator just so you know one last time. So let's start with a 0. So I would start with 9. 9. Remember, always put the parentheses. 1. So I pushed 1. And I hit the division sign for a fraction. 3. Close the parentheses, caret key, 0. Gives me 9. 9 parentheses 1 divided by 3, caret key 1, that gives me 3, so on and so forth, and that's what this whole thing will look like. And remember, this is going to be a decay, but it's going to have a curve. Alright? If you need me, I will be in Mr. Smith's computer lab if you are doing this on 1/26/2017. If you're watching this video at a later date, obviously I'm not going to be there at all. But if you have any questions,